Another type of interest that we have is the compounding interest. So compounding interest is a little bit closer to what your banks do. For example, my bank, my checking account, compounds every month. So at the beginning of the month, I get a dividend deposited into my account of the interest that I earned based on the average amount of that account. Okay, so it compounds monthly is what it does. And they're using a formula very similar to this, where they're taking the principal that was put in, and then based on the rate that they're giving, and the fact that they're compounding monthly, they're able to come out with a value. So here, what you have to keep in mind is that, one, this is going to be your formula. So what you're going to notice is as we go through, I'm going to give you the formula. So do make sure for these next few sections that you definitely print the notes, or that you are constantly referring back to the videos so that you can get used to what the formulas are, because again, for your test, the formulas will not be labeled. So anyway, this is your compound interest. And in this formula, A stands for your future value, P is your principal, R is your rate, T is your time in years, and N is the number of times that you are compounding. Okay, so for example, annually would be compounding once. Semi-annually would mean you're going to compound twice. So it's the number of times that you're going to run this equation over the course of 1 year. Okay, if you keep going, monthly we're talking about 12, weekly we're talking about 52, and so on and so forth. Daily would be, for in most cases, 360. Now I know the argument is that, you know, there's 365 days in a year, but to make things easier, because we are not doing things like counting leap years or counting solstice holidays or anything to that effect, which could expand or condense your calendar, we just say in general a year is 360. Now the other formula we have is called compounding continuously. The only time that you are going to use your PERT formula, see, P-E-R-T, is if you are specifically told that you are compounding continuously in the equation. Okay. Otherwise, if you don't see the word continuously, then you're using the other formula. All right, so let's look at this example here. So the example says, calculate the total amount in the account after the given time period and determine the amount of interest earned for each. So here I'm telling you that P is 2,500, R is 6.5, compounding weekly, and T is 10. So first and foremost, what do we know? Well, my rate is going to be 0.065. And then my N value, or the compounding value, is going to be 52, because there are 52 weeks in a year. So now we have to set up my value. So first, A is equal to P, so 2,500 times 1 plus 0.065 divided by 52, raised to the 52 times 10. Here's how you want to do it in your calculator. 52 times 10, hit enter. Sorry, scratch that. You want to start on the inside of your parentheses. So you're going to do 0.065 divided by 52 and hit enter. Then you're going to go plus 1 and hit enter. You're going to hit your little little hat button or whatever button you need to create an exponent. You're going to open a parentheses and you're going to type 52 times 10 and hit enter. And then you're going to multiply that number by 2500. Okay, so this is my calculator. And so let's see if you can actually see this. I'm going to try and move it so that you can see the screen without too much glare. Okay. So the first thing I'm going to do is 0.065, divide it by 52, and I'm going to hit enter. Oh, gotta come this way. Okay. Now without clearing my screen, I'm going to hit plus. So notice it says answer and plus. So the last answer, this one right here, is still being held in its memory. So you hit plus, and I want to plus 1 to it and hit enter. Again, without clearing anything, I am going to create my exponent. Now on my calculator, my exponent is a little bit different. It's this button right here, so it says x to the something. Now in some of yours it may say x to the y, or you may say see the little caret, or what we call the hat button. So whatever you need in order to create your exponent is what you're going to use. Okay, and so to do that, says I'm now going to hit my little button, so I'm taking my answer, and I want to open a parentheses, and I'm going to do 52 times 10 in my parentheses, close it, and hit enter. It gives me a new value. And then I want to multiply that by 2500. Okay? So notice at no point did I ever clear it or did I start typing fresh. I just kept holding what my answer was inside my calculator and kept going from there. So from here, this tells me that the amount of money that I have earned in my account is going to be $4,786.91. Now the question said to also determine the amount of interest earned. So once you determine what's in the account, to find your interest simply says you got to take what your A is and subtract out your P value. So A again is going to be that future value or the money that's been earned, and P was the money you initially put in. So here I'm going to take my $47.86.91 and I'm going to subtract out that $2,500, which was my initial investment, and that is going to give me the actual interest that my account has earned on top of that investment. So $22.86.91. Now, just as a refresher, if you look at my decimal, oh, I think it was better on this side. Okay, so notice it says 4786.908616. Well, here, the only thing I care about is the 2 digits, so 90, but then I want to round, so I'm going to look at that third. Because this third is an 8, it means 0 rounds up to 1. So don't forget your normal rounding values. So here, this was actually a 2-part question. This is the first answer. This is the second answer. Both answers are required for full credit. Okay. So let's look at the second example. The second example says this time we're going to invest, or your principal is $15,000 with a 6% rate, compounding semi-annually for 25 years. So here, my rate is going to be 0.06, and my end value is going to be 2, because semi-annually means twice. So again, the first thing I need to do is calculate the amount of money that has been earned. So this time I have $15,000 going in. times 1 plus 0.06 divided by 2 raised to the 2 for 25 years. Okay. Again, we'll do your calculator one more time so that you can see it. Hopefully we can see it all a little bit. Oop, maybe there. Alright, so we're starting inside that parentheses. So 0.06 divided by 2 and hit enter. Okay. I'm then going to plus 1 to that and hit enter. I'm then going to raise it, open a parentheses, to 2 times 25 and hit enter. And I'm then going to multiply that by 15,000. I'm then going to look at my 2 digits and round it. So I have 590. 0 doesn't do anything, so it stops at 59. So this is going to tell me that I have earned $65,758.59. Now to figure out how much interest I've earned, again, remembers that I'm going to take my earned value minus what I put into it. So this is going to be the 65,758.59 minus the 15,000 that I put into it to start with. So this is going to give me a difference of $50,758.59. Okay? Alright, so let's look at a couple different types of problems or ways that these could be worded. So in this one it says, suppose your salary in 2012 is $65,000. If the annual inflation rate is 4%, what salary do you need to make in 2020 in order to keep up with the inflation? So this is actually a compounding problem. And so the first thing we need to do is we need to figure out how many years we have. So my T is going to be the ending year, so 2020, minus the starting year, 2012, gives me an 8-year span. Now my rate is 0.04 because it tells me that's the inflation rate. And my end value, well, I'm talking about an annual salary. So that means my N is 1. So here, I need to go ahead and calculate. So this is a compound interest problem where my p-value is the 65,000 times 1 plus 0.04 divided by 1 raised to the 1 times 8. Okay. Again, you're going to plug that through your calculator. So 0.04 divided by 1, hit enter, plus 1, hit enter, raised it to the 1 times 8, hit enter, times 65,000. And you should come out with 88,956.99. Okay? So that's what your salary should be if you were going to keep up with that inflation rate. Nice, huh? All right. Again, let's look at another method. It says a payday loan is made for 6 weeks where the amount of interest owed per $100 borrowed is $20. If you borrow $500 for 6 weeks, how much do you owe at the end of those 6 weeks? So the first thing that we have to know is we have to be able to find total interest. Your total interest is essentially going to be your borrow amount times your interest amount per dollar amount. So I know that's a lot of dollar signs. So let's go ahead and fill it in. My borrowed amount was $500. I'm going to multiply this by the interest owed, which is going to be $20 interest per $100 borrowed. So when I multiply this out, this means that I have been charged a total of $100 in total interest over the course of my small borrowing weeks. Therefore, to calculate the total amount that I owe, I have to take the money that I borrowed, so $500, plus my total interest of $100, means at the end of that time period, I owe back to my boss $600. Okay. Now, for fun, we could also have a sub-question for this one that says to calculate the APR. In other words, what actually was the percent of interest that you had to pay on this account? So there's a few things that we have to look at here to calculate APR. First, we need to know that our APR is essentially going to be what's called your short-term percentage times the fact that we have 52 weeks per, and then the time frame of the loan. Okay. So how do we figure out my short-term percentage? Well, the short-term percent is going to be your $20 interest charged per the amount borrowed. Well, in the problem it said we're going to charge you $20 per $100 that you borrow. So if we're looking at that percentage, this is going to end up being 20%. 20 divided by 100 is 0.2. Convert that to a percent, so that's 20%, which equals 0.2. Okay. So we did this for 6 weeks' time. So my APR is going to be my short-term percentage, so the 0.20, or that 20%, times 52 weeks per the 6 weeks that I borrowed the money. So when we do that math, we actually get 173% APR. So when you're looking at a short-term payday loan, to be perfectly honest, most of them, not worth it. Okay. Alright. Moving right along. You know, I have to say, it is very hard to have my sarcastic, witty moments when I'm talking to myself. But that's okay. Alright, the last problem that I wanted to look at is going to be this one, and notice that this one has a bunch of different points or parts to it. So the question itself says that Angela deposits $2,500 into an account with an APR of 5.5% for 10 years. And then it says find each of the following. So we're looking at compounding monthly, compounding daily, compounding continuously, and then answering the question of which option is going to be better and why. Okay? So let's start back up at the top with compounding monthly. Again, to compound monthly, my N is 12, and my rate here is 0.055. Okay, APR is your rate, 5.5%, convert to a decimal, is 0.055. So what we're going to do is this is a compound interest. So A is equal to the amount put in, 2,500, times 1 plus 0.055 divided by 12, because this is monthly, raised to the 12 times 10 years. So when we do that, we're going to end up with a total of $43.27.69. Okay. And the question wants to know the amount of interest. So remember, interest is equal to A minus what you put in. So this is going to be $43.27.69 minus my 2,500 is going to give me a total interest of $18.27.69. Okay. So this part here, the interest is the actual answer that we are looking for in this problem. Now here we have compounded daily. So again, we are going to look at N being 360. And here my R is the same, 0.055. So I have that A is my 2,500 times 1 plus 0.055 over my 360 raised to the 360 times 10 years. So again, just as one more time, we'll do it together on your calculator. I'll get it figured out eventually. Alright, so we have 0.055 divided by 360. We're going to then add 1 and hit enter. We're then going to raise it, open a parenthesis to the 360 times my 10 years, hit enter. And then we're going to multiply that by the 2,500 that we put in. So notice this is 4332.95. So equals a total of 4332.95. So my interest, again, A minus P, is going to give me $18.32.95. So already, if we were to compare monthly to daily, you would have to notice that compounding daily would be a much better option, as the amount of interest earned is a much higher than it was when we compounded monthly. And let's face it, even a dollar difference is better than anything else. So what we're looking for here is we are essentially looking for which one of these is going to earn you the most amount of money back. Last but not least is compounding continuously. Continuously means my equation has changed. A equals P e to the RT. So in this case, we're going to have 2,500 e raised to the 0.055 times my 10 years. So again, handy dandy calculator. Let me clear this out. Okay. So the first thing that we need to do is you need to find your E button. Now for mine it might be a little hard to see. It's actually right here. And it says E to the box. So yours might say E to the X. A lot of them are, say, up here in your tiny letters right above your buttons. So you're looking for E to the something. And that is the button that you are going to use. So for me, when I push it, my E shows up. Oh, you can't see that. Let's see this way. Okay, so there's my E. I'm going to open a parentheses and I'm going to say 0.055 times 10. Now I'm going to close my parentheses and hit enter. And then I'm going to multiply that by 2,500. Okay, so this is 43.33 and 13 cents. So here, this is 43.33 and 13 cents. So again, when we look at my interest, A minus P, this is going to give me a difference of 18.33 and 13 cents. So to answer which one is better, we have to look at which one has the highest interest comeback. So monthly was at 18.27, daily is at 18.32, and compounding continuously is at 18.33. Notice all three of them are extremely close. However, compounding continuously gives you the highest amount of interest. So here, which option is better to use? You would want to use compound continuously. And to explain why is as simple as it has the highest interest return. So it doesn't have to be super long or super detailed. It just has to be enough to show that you have total understanding or a good understanding of what constitutes a better account than the others. Okay.